Hello and welcome to Backup Academy, VMware vCloud Director and how it works. My name's David Hill. I work for VMware as a Senior Solutions Architect and I've worked for the company since 2010. Prior to that, I was a self-employed IT freelance consultant and I worked for a number of large financial institutions and all of the top four consultancies. My blog site is virtual-blog.com and you can follow me on Twitter at davehill99. So we're going to be looking at this session. We're initially going to start off by taking a look at the key business requirements and why businesses are looking to adopt cloud computing. We're going to take a look at the architecture and how you would design your environment for implementing vCloud Director. And then we'll look at some of the constructs, including virtual data centers, allocation models, and networking. So let's start by looking at the business requirement and why enterprises are currently looking to deploy vCloud Director into their production environments. So what are the key business requirements? Well, some of the main bullet points you can see on the slide here. One of the key ones is business agility. And a lot of people are saying, well, what actually is business agility? It sounds really nice, but what is it? So business agility, you can see there's a list of bullet points there that show you these. So self-service capabilities. These give consumers the ability to come into a cloud environment and just spin up workloads as and when they need on demand. Designed for scalability and elasticity. Well, that allows you to build out environments as and when it's required. So you can start with a small environment and grow as your business needs grow. One of the key points as well is metering capabilities. A lot of enterprises today are looking at being able to provide cost reports to their departments. In the old days, it was a case of IT picked up the tab for everything. Whereas now, businesses are looking to distribute the costs of their IT infrastructure across the multiple departments. So think of it as IT is being the provider and the departments as being the customer of IT. A key one as well is reduce total cost of ownership. By lowering your total cost of ownership, you also reduce your operational costs and make operational efficiencies. You have the ability to prolong legacy applications. So I've seen quite a lot of times people called server huggers who like to keep their servers close at hand, application owners for example. This allows us to move these out and move them into the cloud and still give the management and control to these people who want to own these servers. Now let's take a look at the vCloud architecture. So you can see by looking at this slide that we have multiple components that make up the vCloud suite. vCloud is not just about vCloud Director. You can see that we start with the underlying technology that makes up a virtual environment. So you have the physical layer and the vSphere layer. Now, one key thing to bear in mind when you're looking at this is vSphere is the critical underpinning of everything that makes your vCloud environment. It's what provides the virtualization technology. On top of that, we lay a vCloud Director, which provides the abstraction of the resources in the virtualization layer, and then we can lay a vCloud Automation Center on top, which enables us to have multi-configurable provisional workflows. You see on the right hand side in the green that we have the management solution, so VCOps, vCenter Chargeback, VCM, etc. Looking at this slide, it shows you the different capabilities and how they map to the components. For example, you can see resource abstraction and management is vCloud Director and vSphere. Now, putting these two components together allows you to have that capability. Again, with secured multi-tenancy, you can see that the component vCloud Director and vShield coupled together provide you with those capability mappings. Clouds are built in layers. You start with your vSphere environment and you build out your resource pools, data stores and port groups. You then start layering on top of that your vCloud Director environment. So your provider virtual data centers, you map your resource pools, data stores and port groups through to different service levels, so gold, silver or bronze for example. And then you build out on top of that your organizations, so marketing and finance, which allows you to create your users and policies. Now, an organization is a multi-tenant boundary within vCloud Director. Once you have these created, you can then start building out your catalogs and mapping your organization VDCs by taking some of the resources available from your provider virtual data centers. You can then allocate catalogs and deploy virtual machines from those catalogs into the relevant organization VDCs within that organization. So the architecture of vCloud Director has been designed to be scalable, secure and highly available. Now it scales horizontally at both the application and physical infrastructure layers, so you can build multiple cells to take up different roles and also to provide high availability should a cell fail. From a security perspective, this has been hardened for availability on the public internet. You have user permissions and also the ability to provide multi-tenancy capabilities. You can see in this diagram that we have 3 vCloud Director cells all behind a load balancer. They are all providing different services, but they're all stateless, so they connect through to a database. You can see on this slide that this shows you how you can map to multiple vCenter servers and have multiple cells and carving up the resources. So we have the stateless VCD cells all mapping through to a vCloud Director database, which are all sit behind a load balancer, and these all map to multiple vCenter servers. So you can have up to 10 VCD cells and up to 25 vCenter servers, which allows you to limit the single point of failure. When you think about building out and scaling out your environment, you can start off with a small number of VCD cells mapped through to one vCenter, for example, and then as your demand grows and increases for your cloud environment, you can build out multiple cells. So you can build on that and add more cells and then add more vCenters as you start hitting scalability limits. Now, looking at the logical architecture of vCloud Director in a cloud environment, this is based upon the work that we've done with the vCloud Architecture Toolkit. Now, this allows you to build out multiple resource groups and split it accordingly to your management domains. So you would typically build a management cluster that could have 2 or 3 ESXi hosts in there, and you would run your management components in there. So for example, you would have your vCloud Director cells, your vCloud Director database, the vCenter server that would be used to provide the cloud resources, syslog, Active Directory, for example, and these would all go in the left-hand management cluster. And this allows you to have a management domain, so it keeps these virtual machines and these compute resources away from your cloud resource group. Now you can see on the right hand side we have a gold provider VDC and a silver provider VDC. Again, this would be your compute resources, so your 3 ESXi hosts, typically you would have more, and this would be your cloud workloads. So you isolate these by using multiple vCenters. This again, as we mentioned, allows you to have different management boundaries. It isolates the potential for resource conflicts and provides you with a best practice architecture on how to actually build out your cloud environment using vCloud Director. We're now going to take a look at virtual data centers and what actually is a virtual data center within a vCloud Director environment. Now, looking at this slide, this gives you some examples for provider VDCs. By using a provider VDC, you can now pool your infrastructure together and create standard offerings. For example, you could combine your best-of-breed compute with your fastest storage and create a provider VDC. You can combine your cheap storage and offer it as a silver provider VDC, and offer your more expensive storage, so SSD storage, and offer that as a platinum storage offering. You can offer these as different tiers of service levels and associate a dollar figure with that provider VDC. You could also combine your Nehalem boxes in a cluster and create a Nehalem based provider VDC, and you can combine your AMD boxes and create an AMD provider VDC. Now, within VMware, we typically start giving names for provider VDCs as precious metals, so gold, silver, bronze, and platinum. You could call them whatever you wanted, so AMD provider, Nehalem provider, etc., etc. Some design considerations when looking at virtual data centers. Within the vCloud Architecture Toolkit, we recommend a best practice of using a one-to-one mapping of provider VDCs to ESXi clusters. So you would create your provider VDC, and when allocating that within vCloud Director, you would point it to the root resource pool of that particular cluster. Avoid using large clusters from the start, which allows you to have some headroom for growth. So if you build out a couple of small clusters, say 4 to 8 hosts in each cluster, you can then scale those out as and when you need. As we mentioned before in the previous slide, look at creating your provider virtual data centers to differentiate between performance levels, storage provisioning, service level offerings, or dedicated special purpose requirements. For example, Oracle databases. If you wanted to keep those in a cloud environment, you would have to isolate those clusters as per what is required for Oracle licensing. We are now going to look at allocation models and what these constructs mean within vCloud Director. So what are allocation models? Well, an allocation model offers multiple ways of allocating resources. These are set on an org VDC level, and there's 3 different types of allocation models. These are reservation, allocation, and pay-as-you-go. Now, looking at the reservation pool allocation model, you can see that you have on this slide 2 tenants, and these are fully committed resources. So you would give an allocation to your organization VDC from the provider VDC. So you would typically say, for example, you would say, I want to give 100 gigahertz of CPU, 100 gigabytes of memory, and this is carved up as an always-on set of compute resources. So if you think from a vSphere resource pool perspective, you're setting your limits and reservations to stipulate that you always have that capacity available, whether or not there's virtual machines running. From a cost perspective, it's a very expensive cost model because you always have this available. No other virtual machine from a different organization VDC can take away any of this capacity. It's a great use case if you're looking at doing disaster recovery via a public cloud provider, because you can stipulate the resources you want available, and they're guaranteed, so you know they're always going to be available and always on. But as mentioned earlier, it's quite an expensive reservation allocation model to use. Now, by looking at the allocation pool allocation model, this is a mixture of reservation pool and pay-as-you-go. So you can see, again, we've got the 2 tenants, but they don't have access, they don't have allocated the full 100% of resources. So typically you would set a limit, say 85% of resources available, just as we do in a reservation pool. So you could say, I want access to 75 gigahertz of CPU and 75 gig of RAM. And that is an always-on always reserved set of capacity available to this allocation model. You can then stipulate a percentage of burstability. So you can see the shared area in the middle where these two tenants actually come together. And I guess the way to look at that intersection is it's unreserved resources. So you have the ability to burst up to 100 gigahertz and 100 gig of RAM, for example. And you can use this as a way to allow, if you have stipulated how much compute resource you want, you can use this as a way to overcommit your virtual machines within your cloud environment. One thing to bear in mind is it's not guaranteed the overcommitment area, so that grey shared area. So you will have access to it, but they may or may not be contention for it, depending on how many tenants you have available and how many tenants are overcommitting within that allocation model. Pay-as-you-go is pretty much an unbounded resource pool. So it's just a resource pool that's been created, and there's no reservations or limits set for the workload. So if you imagine you create this pay-as-you-go allocation model, and it is exactly that. It's just you can use as much of the resources available to that organization VDC as you need, and you pay for them when you use them. There's no kind of restriction on how many resources you can have available, so you're not setting the hard and fast reservation limits. But one thing to bear in mind is multiple tenants can consume the resources, so there's no guarantee that they're all going to be there. What you do set from a reservation perspective is you set reservations on a vCPU layer. So you can specify how much CPU a virtual machine itself will consume. And that's typically 1 gigahertz, 2 gigahertz, whatever is required for your workloads. And that, when you create these allocation models and spin up your VMs, they actually create the reservation on the virtual machine layer. So this slide is just a recap on the 3 different allocation types that are available to you when you're creating an organization VDC. So we have pay-as-you-go, allocation, and reservation. This slide also shows you what best fits and what use cases are for the 3 different types of allocation model. One thing to notice is there's a statement there under allocation that says resources pre-allocated and a defined portion is guaranteed. Now that was true in version 1.5, but as of version 5.1, allocation pool resources aren't pre-allocated anymore. They are pre-allocated to the consumer, but not allocated to the resource pool. So this allows service providers to overcommit their clusters without hitting any resource constraints. The resource is allocated as the VApps are powered on, so it's a mixture of across with pay-as-you-go and allocation model. One thing to remember as well is reservation pools also give VM resource control, so you can actually specify what settings you want on those virtual machines as you deploy them. The diagram on this slide shows you the overall networking picture of how it works within vCloud Director. So you can see we have external networks, organization networks, and VApp networks, and these are all connected via edge routing devices, or routing devices as you say in America. You can see that VApp network A and VApp network B are isolated from each other, but they have connectivity through the organization VDC network 1. Again, that network has connectivity out to the internet, but is protected by an edge gateway device. You can route between the 2 organizations, so organization 1 and organization 2, but again, it's protected by an edge gateway. So this just gives you an overview of what you can actually configure with the networking within vCloud Director.
We will start by discussing the three different networking layers, and these are external networks, organization networks, and VApp networks. These networks are managed at two different layers, consumers and providers, and external networks and organization networks are created and managed by the cloud admins or providers. As of version 5.1, an organization admin can now create organization networks. But the difference is a VApp network is created and managed by the user or consumer of vCloud Director, so the person who is deploying the workloads. So let's take a look at an external network. What is an external network? Now, this is a network that is external to vCloud Director. It's created in vSphere. It provides external connectivity to organizations, and as we said, it maps to a port group at the vSphere layer, and this is attached to vCloud Director as an external network. So it allows the vCloud to connect to the outside world. Think of it as exactly that. It is external to the cloud. So if you want to think of a use case for this network type, it could be internet access, network endpoints, so IP-based storage or backup servers. It could be a back-end network infrastructure, so the internal IT infrastructure, access to a second data center. Those are the typical kind of use cases for this network type. Looking at an organization network, this is a network that is contained within an organization boundary within vCloud Director. It allows VApps to communicate within the organization with each other or to the outside organization via an external network. This is backed by network pools within vCloud Director. An organization network can be connected to external networks as a public network, so an external organization direct, private routed, or it can be left unconnected, so it can be an internal organization network with no external connectivity. Again, organization networks are created by cloud admins or providers, as we mentioned, and you can also create these as an organization admin. A VApp network, as I mentioned, are created by users or consumers of the cloud, and these are contained within the VApp container. The key purpose of a VApp network is to connect multiple VMs together and allow them to communicate with each other or communicate to VMs in other VApps via the organization network. Confused? Well, I was the first time I heard all these different pools and network types, but hopefully it will become clearer as we go along. So what can you do with an external network? Well, you have two options. You can create a direct organization network connection through your external network. So you can see at the diagram, the first diagram, there's no firewalls or any kind of technology blocking connectivity between the external network and the organization network, which is called a direct organization network. You also have the option to create a routed organization network, so you have the ability to put a vShield Edge firewall device in between the external organization network and the external network. So you can specify using NAT or firewall what traffic is allowed in from any external connectivity. Provides great isolation if you're looking at setting up lab environments or UAT environments. Let's take a look at network pools. So what is a network pool? Well, a network pool is a collection of isolated layer 2 networks that can be used to create organization and VApp networks on demand and are available to both the provider and the consumer. The provider or your cloud admin would create a network pool before they can be utilized. There's 4 types of network pools that are available in vCloud Director. These are Portgroup-Backed, VLAN-Backed, VCDNI, and VXLAN. Now we're going to take a look at vSphere Portgroup-Backed network pools. So the provider or cloud admin is responsible for creating a pre-provisioned port group on either a standard vSwitch or a distributed vSwitch in vSphere. The provider will then map that port group to the network pool, so it can be used by an organization to create VApp and organization networks whenever they're needed. So the process for the creation of this network pool is you will have to pre-provision the port groups on vSphere, specify the vCenter server on which the pre-provisioned port group exists, add the port groups that will be used by this network pool and a name for it. So as you can imagine, this is okay for a limited number, but it starts causing a challenge from a management perspective if you want to create lots and lots of networks on demand. You have to go in and manually create these port groups. So the advantage, it's the only way to have a network pool using a standard vSwitch. So if you don't have any DV switches, this is your only option. And the disadvantage is it requires manual work to create all the port groups on the ESXi servers and keep them in sync. In VLAN-backed network pools, the provider, or again the cloud admin, is responsible for creating a physical network with a range of VLANs and trunk them accordingly to all the hosts. The provider will then map the distributed virtual switch along with the range of VLANs to the VLAN-backed network pool, so it can be used by the organizations to create VApp and organization networks whenever needed. Each time a VApp or an organization network is created, the network pool will create a DV port group on the distributed vSwitch and assign one of the VLANs from the specified range. Each time a VApp or organization network is destroyed, the VLAN ID will be returned to the network pool, so it can be available for others. So for the creation of this network pool, you will have to provide a range of VLAN IDs and the respective DV switch, which is connected to the uplink ports that are trunked within that range of VLANs, and a name for it. So if you imagine you can have a range of say 200 VLANs pre-created on your network switches, you give a port on your DV switch that has those, and then you say to vCloud Director, here's the range, I have 200 VLANs, consume these when you need to create networks. So the advantages is some people perceive this as the most secure network pool type. The disadvantages is you have to pre-create these VLANs within your network. So somebody within the networking team has to go and create these 200 VLANs. They have to exist on the physical switches. You then have to create the port group within vSphere and allocate that to vCloud Director. VLANs as well, if you think from a service provider perspective, VLANs are a limited resource. You have a limit of 4,096 VLANs, so there is quite a large likelihood, if you're a service provider or very large private cloud provider, that you can hit this limit and scalability restriction by using predefined VLANs. So you can see here how this works. We have a DV switch with multiple port groups with the VLAN ID. So you can see 3931, 3932, and then VMs associated with that port group. Now, this is quite similar to Portgroup-Backed. However, Portgroup-Backed are all manually created. These are automated in the sense of vCloud Director will tell vSphere to create these port groups on demand when you need them on the DV switch. Now moving on to VCDNI backed network pools. This is one of two network pools that allow you to have more of the on-demand provisioning aspects of a cloud environment. So anyone who's seen myself and Chris Colotti present at any VMworld sessions, This is, it used to be the only one, but with the introduction of VXLAN that's kind of changed. But we used to say that this network pool was the one that makes cloud cloud. So it enables you to create the on-demand networks as and when they're required. Okay, so the standard practice to create a VCDNI network is to use a VLAN as a transport layer, much in the same way as you would set up your vMotion networks across hosts. You would have a single VLAN that's non-routable. You would follow that same practice to create the transport layer for VCDNI. It's only accessible by the hosts providing your vCloud resources, and then this network pool uses this transport layer to pass the encapsulated traffic to the different hosts. Now VCDNI works by using a Mac-in-Mac encapsulation. You can see in the diagram the Ethernet frame and which parts of the packet, the header, and what actually gets added on from the encapsulation perspective. So physical switches see these packets, but they simply see them as packets destined for an ESXi server. One of the things that you need to do from a networking perspective is increase the MTU. So the default is 1500. Now we recommend that you change this to 1600. It used to be 1524 because it adds 24 bytes to the Ethernet frame. But because of the introduction with VXLAN, we recommend now that you just increase the MTU size on the physical network to 1600, which allows you to either use VCDNI or VXLAN or grow the network as you need it. Now, one thing to bear in mind is this encapsulated traffic is not encrypted. So if you give any other host access to that VLAN transport layer that we were talking about, then they will be able to see the encapsulated packets and the payload. Some best practices around VCDNI, briefly mention them. Don't connect machines to the underlying transport network directly. As we mentioned on a previous slide, it's unencrypted and visible to any machine directly connected to that transport layer. Always use non-routed LANs or VLANs as a transport layer. It's in today's modern networking, I don't know many people who would create a physical LAN just for a transport layer when you can easily create a VLAN. So bear in mind that always create a non-routed VLAN. So how does VCDNI look on the vSphere layer? You can see on this screenshot here that we have multiple port groups using the same VLAN ID 3930 with different VMs connected. So you have two vApps, each using a routed vApp network. So you can also see that there's a VM on there called a VSE, that would be your vShield Edge. So it's created two port groups from that network pool on the distributed virtual switch using the same VLAN. But it uses the DV filter to encapsulate this traffic. The basic use case for VXLAN is to connect two or more layer 3 networks and make them look like they share the same layer 2 domain. So this would allow for virtual machines to live in two disparate networks yet still operate as if they were attached to the same layer 2. You need a few components in place to use VXLAN, so multicast support, VXLAN network identifiers, a VXLAN gateway, VXLAN tunnel endpoint, and VXLAN segment overlay networks. Now, the great thing about using VXLAN with vCloud Director is once you've configured your multicast scopes and done your network preparation within the vCloud Networking and Security Manager, vCloud Director will automatically create your virtual wires or a VXLAN segment. So it makes it a lot easier to stand up your VXLAN networks across your layer 3 networks. You can see by looking at this slide as well, the original Ethernet packet has now grown, so it has 50 bytes of overhead instead of, as we've seen in the previous one, with 24 bytes, which is why we now recommend to increase the MTU to 1600. And you can see the extra parts of the packet that have been added, and you can see the VXLAN encapsulation in the diagram below. Some of the VXLAN benefits include the ability to create 16 million isolated virtual networks, scale past the 4096 VLANs limitation. You can create up to 1,000 isolated networks per network pool. And one of the great things about VXLAN, much in the same way as VCDNI, going back to it's what makes cloud cloud, is it allows you to have the ability to automate the provisioning of networks on the fly and on demand as your consumers need it. So when you think of a cloud environment where there's multiple virtual machines spinning up and getting deleted, and very elastic environment, the benefits are just unbelievable when you think about it. Just creating and deleting networks as and when you need them. It's a real benefit to the cloud infrastructure, and without these networking capabilities it would be very difficult to have automated networking provisioning. So what is an organization network? Let's start with what they are. So an organization network is created by the cloud admin, and these are contained within the organization boundary. It allows VApps to communicate with each other or to communicate outside of the organization, so via an external network. They can be connected to external networks as direct networks, routed networks, or they can be private, internal, isolated networks. You can see via the routed one that we have an edge firewall in place to keep that network segregated, and the bottom diagram shows you the isolated, so it has no external connectivity, but the VApps are allowed to communicate across that network. Now a direct organization network, which is a direct connection to the external network, you can see in this diagram that the VM is connected to the organization network via a direct connection, and that has a direct connection to the external network. Now you can see the orange line is actually showing you what's really happening. That VM just has a connection to the port group that's created for your external network. Now a routed organization network has in place a vShield edge, which is used as the virtual router or the virtual gateway. That has a NIC connected to the isolated port group and a NIC connected to the external network, and it routes the traffic through the edge device. You have multiple services available to the organization network, so NAT, firewall, DHCP. You can do SSL VPN connections, static routing. Okay. An isolated internal organization is exactly that. It's just an isolated port group on a vSwitch. So if you imagine in the older days when you used to create lab environments, we used to just create a vSwitch with no uplinks and create port groups on there and attach your VMs to it. So you could have all these VMs talking to each other without them actually leaving the host. This is a very similar situation. The one thing to bear in mind is the only networking feature available to an isolated network is DHCP, and any VMs connected to an isolated network cannot communicate with anything externally available to the cloud. It's purely isolated. So there's some considerations when looking at IPv6 and vCloud Director. Currently as version 5.1, the VCD GUI does not support IPv6. The workloads support IPv6. So, for example, you can have Windows 2008, running IPv6. Now, as long as you're not using a vShield Edge to route any traffic, so say you have a direct connected external network, you can use IPv6 on that workload operating system. As soon as you introduce any of the networking features like vShield Edge or any configuration items like that, then you lose the ability to use IPv6. So consider the use of an IPv6 to IPv4 tunnel while trying to work around these restrictions. So thank you for attending this presentation on vCloud Director. I appreciate your time, and I hope it's been beneficial to everyone who's watched it.